Hi there, Ms. Lams here. In this video, we're going to talk about t-tests on the following. So types of t-tests, a brief theory about the t-test, application and reporting on the t-test, and t-value versus p-values. So just want to show a disclaimer that I'm not an expert in statistics, so just some very brief general guidance. Please feel free to research and read a little bit more for better understanding. Links are in the video description below. Now, this video is updated on June 2022. All right, so first one is what is t-test? So basically, it's a statistic test to check if there's a significant difference between two sets of discontinuous data. So you will use it when your IV is discontinuous, so where you have a bar chart with two bars. Generally speaking, you need to have at least 10 repeats per increments to run the t-test. Of course, the more the better. There are two types of t-tests. One is known as the one-tail t-test. And you will conduct the one-tail t-test when you know that your comparison is directional. So for instance, you know that which one is higher or lower. And the second one is two-tail t-test. And you will conduct the two-tail t-test when the comparison is non-directional. For instance, you're not sure whether the effect of your IV is increasing or decreasing the effect. So the second part is a brief theory about the t-test. So first of all, like all statistic tests, we will set up a null hypothesis. So also sometimes notation is H0. So a null hypothesis means that there's no significant difference between A and B. It's assumed to be true, and statistical evidence is required to reject it in favor of an alternative hypothesis, H1. So alternative hypothesis usually relate to your research question. And in order to support the alternative hypothesis, you need to reject the null hypothesis. Okay. And some students will say that, oh, why don't we just do something to support the alternative hypothesis directly? It's because there could be more than one alternative hypothesis. That's why we need to conduct a statistic test, and we look at the p-values and see based on the p-value whether we should accept or reject the null hypothesis. Okay, so null hypothesis and alternative hypothesis. So just now we mentioned that alternative hypothesis more related to your experiment RQ. The null hypothesis, usually when we set up, we just put a negate or no significant difference in the statement, okay? So then the next part is the p-values. So like a lot of statistic tests, at the end of the day, you obtain the p-values. Okay, and based on the p-value, we will decide whether to accept or reject the null hypothesis. So if the p-value is more than 0.05, then null hypothesis is rejected. So in the scientific community, we accept about 95% confidence. So that means that what we claim your statistic test does is significant, and 95% not due to chance. So of course, if your p-value is really, really small, then you can be even more confident in your statistic test. So for example, if your p-value is more than 0.01, that means it's 1% significant level, 99% not due to chance that this, what your statistic test does, happen, okay, and so on. Okay, so next one is like, for example, p-value, always we mention about p-value, why do we compare against 0.05 to 5%? Because generally speaking, in the scientific community, we accept about 95% confidence, okay? So that means that about 5%, if you split about two sides, so the positive end and negative end, so that means about 2.5 here, 2.5 here. Okay, very unlikely observations. This is where the p-value lies. So if your p-value is more than 5%, that means that you are more than 95% confident that what you state is true, is supported. Okay, so that's the idea about p-values. Okay, so t-test. Okay, so we have one-tail t-test and two-tail t-test, and we just briefly mentioned when do we use it. We use one-tail t-test when you know that the comparison is directional. That means you know that which one will be higher or lower. And you will conduct the two-tail t-test when the comparison is non-directional. So sometimes students will ask me, oh, Ms. Lam, which one do you prefer? Generally speaking, personally, I prefer to do the two-tail t-test because the reason is that I find it slightly easier to set up the null hypothesis as the two-tail t-test is non-directional. So basically, all I'm checking is whether there's a statistical differences between the two sets of data. As to which one is higher or lower, you can just check the average and you will know. However, okay, easy and correct is different, right? So you should do the correct way. Okay, so you will use one-tail t-test when you know the direction of the comparison. So for example, if you know that, oh, vitamin C will have a positive effect on the plant growth compared to the one without vitamin C, just pure water as the control, then you are actually only interested to see if fluency is significantly higher than the water. So in terms of the distribution curve, you prefer to just look at what happens here. What happens, oops, sorry. What happens, oops, sorry. Okay, so you were just concerned about what happens in the positive end, okay? So one-tailed t-test is actually more suitable for this experiment because all the p-values dedicated to one side of the argument, okay, of this one side of the curve, okay? All right, rather than two-tailed t-test, okay? So you should be using one-tailed t-test if you know the directions. Okay, so another more to read about one-tailed t-test, you can pause the video to read it, or alternatively, you can just refer to links in the video description below. Okay, so the third part is the application and reporting the t-test. So for example, if you decide to do the one-tailed t-test, okay, knowing that there's a direction. So assuming you just want to know if filament C has a significantly higher plant growth rate compared to the control, then first of all, you set up the null hypothesis. So for example, filament C does not have a significantly higher plant growth rate than the control. So then we use Excel to calculate the p-values. So the formula is equal sign, and then type t-test, and then bracket, first set of data, comma, second set of data, comma, 1, comma, 2, close bracket, okay? So after this, then you should come with a, end up with the p-values. And if the p-value is greater than 0.05, then you will accept the null hypothesis. That means that at 5% significant levels, 95% not due to chance that filament C plant growth rate is not significantly higher than the plant growth rate in the control. Okay, however, if your p-value is much smaller than 0.05, then you will reject the null hypothesis, saying that, oh, at 5% confidence levels, 95% not due to chance that filament C plant growth rate is significantly higher than the plant growth rate in the control. Okay, so the format of reporting the one-tailed t-test is that first of all, you state the p-values. So for example, I have a p-value like 3.14 times 10 to the -8. So it's a really, really small value. So I can say that at 0.1% certain levels, 99.9% not due to chance that this, what you claim, is significant, okay? So I just want a reminder that a t-test can only be used to compare 2 sets of data at a time. If you have 3 sets of data to compare, then you should use ANOVA. Okay, so next part is what happens when you do a two-tailed t-test in Excel and how you report it. So when you do not know the trend, okay, so you don't know whether it has a positive or negative effect on the result. So first of all, you set up the null hypothesis. So for example, filament B does not have a significant differences in plant growth rate than the control. So again, you use Excel, and then you type equal sign, t-test, bracket, first set of data, comma, second set of data, comma. This time is 2, comma, 2, comma, close bracket. Okay, so that's the two-tailed t-test. Again, you get the p-values. If it's greater than 0.05, accept the null hypothesis. That means that at 5% significant levels, 95% not due to chance that there is no significant differences in plant growth rate in filament B and the control. Okay, and if the p-value is more than 0.05, then you will reject the null hypothesis, saying that at 5% certain levels, 95% not due to chance that there is a significant difference in plant growth rate in filament B and the control. Okay, so like all the t-tests, you first of all state the p-values, what have you calculated, state the significance level, okay, and state the conclusion of the t-test. Okay, right? So last part, we will talk about t-tests. Sometimes when a student were researching about t-tests, they might come across the word t-value and p-values. So what's the difference? Okay, so t-values, first of all, I recommend you not to do it. And the reason is because t-value is a manual way of doing the t-test. And actually, there's no extra mark for doing it manually. In fact, according to the examiner feedback, they say that a lot of candidates have mixed up the t-values and the p-values. So strongly advise you not to do the t-values. So t-value is doing the t-test manually, and t-value is not the same as p-values. It will involve some statistic terms such as degree of freedom or critical values, and the interpretation is quite opposite. So you will reject the null hypothesis when the t-value that you calculated is greater than the critical values. Okay, so we can do more reading on that if you're interested. So for example, like I said before, it's a manual way of calculating the t-test, right? So you calculate the t-value using this formula. And then, for example, let's say you have done 30 trials, degree of freedom will be N-1, which is 29. So you go for the statistic booklet, check for the data table, and degree of freedom is 29. And then at 95% confidence levels, 5% significance levels, you have your critical value at 2.045. Okay, and then based on this calculated t-values, okay, if the t-value is greater than the critical values, so if the t-value that you calculated is greater than 2.045, then you will reject the null hypothesis. And for example, if the t-value is smaller than the critical value, then you accept the null hypothesis. So since there's no extra mark for doing it manually, I would strongly recommend you to not to do a t-value, just do p-value, let the Excel do its job. In conclusion, so calculate your p-values, and if your p-value is more than 0.05, then you can reject the null hypothesis. Yay! All right, so I hope you will find this video useful. And bye for now.